All right, this example is actually one that could mean something to us in terms of projections, so it'll actually give us some information that we might care about rather than just a bunch of formulas that don't really mean anything to us. So we're going to talk about force in terms of this person sledding down the hill. So it says that Juan is sitting on a sled on the side of a hill inclined at 45 degrees, so that's important. 45 degrees. The combined weight of Juan and the sled is 140 pounds. That's important as well. We want to find out the force required for his friend to keep him from sliding down the hill. Now, it's 45 degrees down the hill. It's assumed that this is going to be easier for her to hold him up on an incline than it would be if she were just holding him directly up in the air. So what we should find at the end of this problem is that the amount of force required for her to put on this rope is less than his total weight, which is 140 pounds. Now, we're going to, in order to do this, you'll see a couple of vectors here. We've got F, the force of him on this sled, and it's going to be a projection onto V, which is actually the hill in this case, the 45-degree hill. So we are going to do a projection of F onto V, which is this whole sledding hill. Now, in order to do that, so I guess I should probably write down the formula first, see what order it's in. The projection of F onto V is what we're going to be doing. So we're going to have to follow the formula from back before, but we've got to figure out the vectors first. Now, the force vector is just how much weight Juan is putting down on this hill. And I want you to think about it first of all as if, what if he was just sitting on a flat surface? If there was 140 pounds just sitting on a flat surface, then we would have a vector for force of 0 in the x direction. He's just sitting there. And then negative 140 in the y direction because he's going down. So that's the force vector that we're going to use here is 0, negative 140. For the vector that we're projecting onto, it's the hill here. So all we really have for that is an angle, that 45 degrees. And if we don't have a magnitude specified, we might as well make it the easiest number possible. And that's going to be a unit vector. So we talked about unit vectors a little bit from before. That was from previous section. But a unit vector, the formula for it involves cosine and sine. So we're going to do cosine of the angle, sine of the angle, and that's going to get us our unit vector that we care about here. Now, if you'll remember also from just what we know about right triangles, cosine and sine of 45 are both square root of 2 over 2. So we know our vector that we're projecting onto. We just have to have something as kind of a basis for where we're going with this force vector. Now that we have those two vectors, we're going to plug them into the formula. And so the formula, just like in the last one, we're going to start in the top with the dot product between those two. So the dot product is 0 times square root of 2 over 2 plus negative 140 times square root of 2 over 2. Sorry, that 140 looks a little hard to see, but that is a negative 140. Now on the bottom then, we're going to take the magnitude of our vector v, but I want you to think about what kind of vector we made here. The vector we made is actually a magnitude squared, actually, is what we're looking at here for that. But the vector that we made is a unit vector, so the magnitude is 1, so this is just going to be, this whole thing is just going to be equal to 1 because of the fact that 1 squared is 1. Now the other thing that we need is we need to have our vector v on the outside too, so that's square root of 2 over 2, square root of 2 over 2. We're just making a vector for the projection to see where is this sled going. We simplify things here. what ends up happening on the top is that we get, well, that's 0. Negative 140 divided by 2 is negative 70. Square root of 2. That's what's on the top here, all divided by 1. And then we have times square root of 2 over 2, square root of 2 over 2. Building our vector. Now what we would want to do is we want to distribute this in. Luckily it's going to be the same thing on both of those. And if you'll notice, square root of 2 times square root of 2 is 2. So that's going to be 2 divided by 2. So all those 2's basically just cancel out. And what we get for this vector is negative 70, negative 70. That's the vector of Juan going down the hill in this sled. And we want to know how much force it takes for her to hold him up. So the amount of force required is just going to be, let's find the magnitude of this vector. So that's going to be the part that we actually care about in this problem, is the magnitude of negative 70, negative 70. And we can use our same old formula from before, square root of negative 70 squared plus negative 70 squared. Punch that into the calculator, let the calculator do the work there, and we are looking at approximately really close to 99 pounds of force. So if she's going to hold him up to the top of this hill, the nice thing is she doesn't have to lift 140 pounds, she has to lift 99 pounds at least just to keep him from sliding down.